Okay, here once again we meet each other again. So today I will continue giving examples on how we solve problems that involve force formula. Yeah. Okay, now we look at example number 2. A force of 4 Newton is applied to an object of mass 0.5 kilogram and cause it to move with a constant velocity. Okay, as I always mention to you guys, that we must highlight information given by the question. Alright, so we read again. A force of 4 Newton, right, is applied to an object of mass 0.5 kg. So a mass of 0.5 kg and cause it to move with a constant velocity. Now all this kind of information is very important for us to consider. Now we need to move to the question. A. What is the resistive force against the motion of the object? So we need to visualize the system of the motion. Alright. So our solution will be here. Okay. A. Solution. Alright. So we have a body. Alright. With mass 0.5 kg moving, right? Moving with force equals to 4 Newton. Now that information we get from this question. Alright, so the question now asks you to find resistive force. So meaning now this object is moving, let's say moving towards that direction, right? From left to right with 4 Newton. And then if a body move exists, right? Always exists resistive force. Okay? Which move the other way around, the other direction of the movement of the body. Alright. But one more information that is given to us, it says constant velocity. What does it mean? Constant velocity meaning there's no acceleration. Alright, no acceleration, 0. So first we need to find net force. Net force means the initial force moving to the right hand side and the resistive force moving to the left hand side. So we write our formula. Let's say this resistive force as R. So if we want to find net force, you must minus F minus R. Then we get net force. So in our formula, we write F minus R equals to mass times acceleration. So in that case, we further our calculation. We need to find our resistive force. What is this? That is what question 1 need to find. So we substitute all the values that we have. 4 Newton minus R equals to mass times 0 acceleration. Oh, sorry. I need to substitute the value. Okay. So what I do, I write 0.5 kg multiplied by 0. Alright, then we have 4 minus R equals 0. Then, what happened to this 4? We bring to the other side, we get negative R equals negative 4. Therefore, our R equals to 4 Newton. That is our resistive force. Alright. Then we move to the next question. Now, if the applied force is increased, okay, if the applied force is increased to 10 Newton, will the object experience acceleration? So, in the first question, it says constant velocity. Constant velocity means zero acceleration. Now, if the applied force is increased, we increase the applied force to 10 Newton. Will the object experience acceleration? Yes, it will experience acceleration. Okay, we can prove this through calculation. If yes, calculate the magnitude of the acceleration. So we need to find the new acceleration. Okay, now we use the same formula, right? But as I said, I always mention this to you, we need to draw the diagram to help us understand the problem better. Okay, move. But now it is not 4 Newton. Moving with 10 Newton. And then the resistive force is 4 Newton. We already determined this in question A. So now we need to find acceleration. Alright, we need to find acceleration, as we can see here. If yes, calculate the magnitude of the acceleration. So, we use the same formula. Sorry, I forgot to write B here. Alright, there. So, we write our formula as the same formula, F minus R. This is our net force. Okay, equals to mass times acceleration. So, our force is this one. 10 Newton minus 4 Newton equals to 0.5 A. We don't know what is A yet. So 10 Newton minus 4 Newton, we get 6 Newton equals to 0.5 A. Alright, so we solve this equation for A. So 0.5 A equals to 6 Newton. Then we divide this with 0.5. Here also 0.5. And A equals to 12. Alright, so as simple as that. So that is one example that I like to share with you. And in the next video, I will share with you another example, yeah? Alright, guys, see you soon, and stay safe and stay at home.